So question 4 is referring to periodicity, and whenever I am looking at periodicity, I am referring to the effective nuclear charge in the atom or ion. The effective nuclear charge is given by the notation ZF and is just equal to the nuclear charge Z minus the amount of shielding S. As we go across a period, the nuclear charge increases as you are adding a proton to the nucleus. And as we go across the period, the shielding doesn't change substantially because we are continuing in the same shell. As you'll recognise from your ionization energies, it does vary slightly at particular points as we enter new subshells, going from group 2 to group 3, and as we doubly fill an orbital, going from group 5 to group 6. However, the change in shielding is never significant. So the increase in Z and the fact that shielding stays roughly constant means that the effective nuclear charge is going to increase. If the effective nuclear charge increases, that means that the attraction for the outer electron or the delocalized electron increases. Final point we need to make is what is a metallic bond? And a metallic bond is the attraction between its positive ion and the delocalized electron. If the attraction increases, the metallic bond is going to get stronger, and therefore the melting point, which is the energy required to break that bond, is going to increase. As we go to the next molecule, or the next question rather, we're looking at covalent molecules. So in this context, melting is a physical process, so we're talking about intermolecular forces here. As we're comparing sulfur with sulfur, there's no difference in electronegativity, and therefore we're talking about London forces. Same again for chlorine, there's no difference in electronegativity between chlorine and chlorine, and therefore we are talking about London forces. In S8, there are 8 sulfur atoms. Each sulfur atom contains 16 electrons, so that is a total of 8 times 16 electrons. Each chlorine atom contains 17 electrons, so that is a total of 17 times 2, which is 34, and 16 times 8 was 80 for the 80 for the 10 times 8, and then 48 for the 8 times 6. 80 plus 48 is 128. There's significantly more electrons in the S8 than there is in the chlorine. The number of electrons is proportional to the London forces, and therefore there's significantly more London forces in S8 than there is in chlorine, and therefore the melting point of S8 is going to be significantly higher. For the atomic radius, again we're talking about periodicity, so again we're talking about effective nuclear charge, and again the nuclear charge increases, the shielding stays roughly the same, and therefore the attraction increases as the effective nuclear charge increases, and if the attraction increases, the distance to the outer electron is going to decrease, and therefore the radius is going to decrease.